Alright, let's determine the equation of this graph, and we're not given anything other than the graph. So we're going to determine the equation in the form y equals to a sine and cosine k x minus d plus c. So the main points we need to find are a, k, d, and c. So let's get started. So from here we can see that the maximum value here is 3. So you could say max is 3. Minimum value is this one, and that's -1. Minimum is -1. And from here we can find that the c value, which is the average of the two, and the c value is also the midline, is 3 plus minus 1, which is 3 minus 1, which is 2, and you divide that by 2 because you're taking the average, and it gives you 1. So right away we found c. Now let's go on to k. So and this right here, not number 1 on the y-axis shows the c value. Now to find k, we need to know what the period is first, because if you remember, the equation for the period is 2 pi over k. So switch these around and you get k is equals to 2 pi over the period. Now what's the period? Well, we can look at it from here to here. This seems like it's going up and down and then coming back. It's going to come back up, right? So essentially it's if we look at this point from the origin, it's going like this and then it's going to come back up. So this point here corresponds with this point, and this point right here corresponds with this point right here. Well, if we know that, then we know that if half the period, and the period is just when the graph does one cycle without repeating itself. So the period would be from here to here. Half the period would be from here to here. A quarter of the period then would be here to here. So that this tells us that from here to here, this is 1/4. This is 1/4 the period. So then all we need to do is get what that is, and then multiply by 4. So what is it? Let's see. So this is 5 pi over 12. From here to here is 5 pi over 12, and then you're subtracting this much to find the area of this. So let's see. 5 pi over 12 minus pi over 4. Multiply the top and bottom by 3, and this becomes 5 pi over 12 minus 3 pi over 12. Over 12, and this will give you 2 pi over 12, which will give you pi over 6. So that's a period right there. So the period is 5 pi over 6. So then we can put that into this equation. 2 pi over 5 pi over 6. Well, the rule is you multiply this value by this, and this stays as a denominator. So 2 pi times 6 over 5 pi, and the pi's cancel out, and this becomes 12 over 5. This becomes 12 over 5. Oh no, we forgot to do something. We forgot that this right here is not the period. This is 1/4 the period. So then the period is this times 4, which is 4 pi over 6, which is 2 pi over 3. So then we can put it into here. 2 pi over 2 pi over 3. That gives us 2 pi times 3 over 2 pi. And obviously these cancel out, and you get 3. So k is 3 then. Okay. We have we have c, k. Let's find a. Well, what is a? It's the amplitude. It's basically, if you take a point from here, how far does it go up? And if you look at it from here, how far does it go down? So we could see automatically that, well, if this is 1 and the max is, what is it, 3, so it goes up by 2, right? 1, 2. So that means a is 2. The mathematical way to find this is a is max minus min divided by 2. So 3 minus 1 is plus 1. Plus 1 divided by 2, that's 4 divided by 2, which is 2. So a is 2. Right? Okay. Finally, d. Now it turns out for any graph you're given, let me just erase all this. Any graph you're given, it's going to have a cosine equation and a sine equation. Let me show you why. So this graph, this starts from the origin here, right? Well, okay, the sine of the sine equation for this, actually let me write it out first and then I'll explain. So the d value, how much is translated over, would be the value from here to here. Alright? And that's pi over 4. Why is it from here to there to there? Because remember, a sine graph starts at the origin. So sine graph would be like this. Cosine graph would be like that. Something like that. So if the sine graph starts at the origin, then well, you just see how much has it been shifted over from the origin. Well, you see that it should be here, but it's now here, and the corresponding is pi over 4. So then you could say that the d for the sine is pi over 4. Okay, how do you get the d for the cosine? Well, remember, like I said earlier, the cosine graph starts at 1, comes down to -1, goes back up, and goes like that. Well, if it starts at the top, then what we could say about this graph is, well, this would be the cosine value. This, if the origin was to be here, if the origin was to be here, right? Then, and the graph started here, this would be a cosine equation. So then you see, well, if this is obviously not just y equals to cos x, because it's been shifted over. How much has it been shifted over by? Well, you see that the x coordinate corresponded with this point right here is 5 pi over 12. So that's how much? 5 pi over 12. And it's a positive because it's been shifted to the right. If it was a negative, this value right here would be a negative and then minus d, which would give you a positive. Whereas in this case, this is a positive, so it gives you x minus and then a positive d value is still minus. Okay, so then with these, we can find, or we can complete the equation. So this would give us y equals to a is 2. So, and remember, a, c, and k stays the same for cosine and sine graphs. It's just the d that's different. So 2 sine 3 x minus pi over 4 plus 1. And for this one, it's y equals to 2 cosine 3, everything stays the same except for the d value. and then we have a value, k, d, and c for both of them. And now let me tell you why you have two equations for one graph. And you probably already figured this out. If you did, we're all done, nothing else. But if you didn't, let me show you. So like I was saying before, this graph here can be a cosine and a sine equation. That's because if you move the graph over pi over 4 units to the left, this starts here, and then it becomes a sine because it starts at the origin. Move it 5 pi over 12 units to the left, and this value starts. Okay then. That value would start over here at 3, and then it would be a cosine graph, because if you have a sine x graph, so let me draw that. So sine x would be like this, cosine x would be like this. Right? So what do you notice? If you take the sine graph and just move it over a little bit, it's the same thing as a cosine graph. Is it not? Or similarly, because the cosine graph and the sine graph as well continues forever, right? So if you move the cosine graph over a little bit, it's the same as the sine graph. See, this point would go over here, meaning this point would go over here, right? This point would go over here, this point would go over here, and so on. So that's why the cosine and sine graphs are very related. It's just that they're shifted over a little bit. And that's why we have two equations for this one graph, because we can say that, oh yeah, this is a cosine graph or a sine graph. If your teacher asks you to say, express this equation or this graph in terms of its parent function cosine, then you'd use this one. But if they said sine, then you'd use this one. And one trick to remember is, yeah, I could have I could have taken let's see, for the k value, right? You're taking the period, but it's best to take the period, or not for the k value, sorry, for this d value. You can take this point for sine, but it's best to take this point. It's best to take the point when the instantaneous rate of change is positive. Right here it's 0, right here it's increasing, and what that really means is, for the d value for sine, take the point where it's touching the midline, and then it's going upwards. So this here is going upwards. That will give you a positive d value, which would make your it would make your equation just easier to read. And your teacher might want this. This is how my teacher wants it. But see, if I chose a different point for d, this might have been plus something. We don't know. But since I chose this point where it's going upwards, this is a x minus pi over 4. And for cosine, you always choose the nearest to the right hand side, so you don't take you don't take anything on the left hand, you take something on the right hand. So the nearest right hand side maximum value. So I chose this instead of, I don't know, this, because this is also a valid point. If you shift this over this much, then yeah, that's still a cosine graph, but it's just been flipped, so the a value would be a negative. So it just makes your life easier to take this value as well as this value. So this would be the d for cosine, and this would be the d for sine. And always do it like this. if you have a graph, if you're given a graph like let's see, I have one here. So if you're given a graph like that, right, and then it cuts off, it doesn't show you anymore. Well, what you could do is you could say that, well, if it did show you a bit more, it would be like that, right? So if you're given these 2 points, and I'll make a video on this, but if you're given these 2 points, well, you know that they correspond to these 2 points. That's half the period multiplied by 2, and that's the whole period. But if that's half the period divided by 2, and you get how much it's going by, whatever that value is, add it to this value, and you'd get the point here. Or this is here, you'd get the point somewhere over here, yeah? And then you could easily find the d for the sine. You wouldn't need to use this, and say this was the midline here. You wouldn't need to use this one, you would still be able to use this one. And remember, it's going up, so that's the one you should be using. But yeah, it's been a long video, and that's it. Those are some of my advices, and this is how you do the graph.